Good morning to all. I am Dr. Amina Priyadarshini, Professor of EC Department. In today's class, we shall discuss about the bandwidth consideration in communication systems. So, bandwidth consideration, first of all, what is bandwidth? So, often we have discussed that bandwidth is the difference between the upper cutoff frequency and the lower cutoff frequency, which defines the range of frequencies that has been allotted for a particular communication. In case of industrial communication system, bandwidth, which refers to the data capacity of a network link. Typically, this bandwidth is measured in terms of bits per second, which indicates that within a second, how many bits are transmitted. So, uh, clearly, it defines the capacity of a system. So, the for efficient and reliable communication, the bandwidth plays an important role. So, the calculating the bandwidth as well as managing the bandwidth and which maintain the um, is an important parameter to maintain a effective communication. So, bandwidth is the maximum amount of data that can be transmitted over a communication channel per unit time. So, the core principle of bandwidth calculation involves determining the total amount of data that needs to be transmitted within the specific time frame. So, in industrial context, this requires summing the data rates of all connected devices and protocols within the system. So the factors which are affecting the bandwidth in industrial networks are first one is industrial protocols, just adding the overheads. So the overhead means which consists of in addition to our data, original data, we are including some headers, checksums as well as control data. So all these things consumes 30 to 70% of raw bandwidth. So it consumes a large amount of data bandwidth when compared with data transmission. So next parameter which affects the industrial bandwidth are real-time requirements. So the real-time requirements which is of two, that is hard real-time as well as soft real-time. So hard real-time means it includes the motion control as well as robotics applications which consumes some certain amount of bandwidth. Which next is soft real-time. So that is monitoring as well as SCADA operations. Also this also affects the bandwidth consumption. So next, higher the real-time performance, it consume more amount of bandwidth, or large amount of bandwidth should be reserved for its applications. So the third parameter which affects the band considerations are the number of devices. So which includes the number of devices that are connected within the network. As the number of devices increases in the network, the bandwidth consumption is more. So the bandwidth requirement is more, and the band requirement which depends upon the number of devices. So number of devices means in a network which includes number of sensors, actuators, all these things. So as the increases, the requirement also increases, and also the data per device. So each device for its operation supports a particular data rate. So the device data per device it also plays an important role, and also the update frequency. As the frequency is increased, more data rate can be supported by the system, and which occupies a large bandwidth. So next is the typical cycle time. So typical cycle time, it is defined as the ratio of update rate to the cycle time application. Next, the motion control. So motion control, usually it lies between the time duration for this motion control lies between based on the application. It is from 250 microseconds to 1 milliseconds. So for PLC IO cases, the motion control time requirement is of the range is of 5 to 20 milliseconds. In case of SCADA operations, it is of 500 to 100 milliseconds. The last consideration is the network topology. So the type of the topology we have preferred is also plays an important role for the bandwidth requirement. So here first is the star topology. So by using this star topology, the bandwidth requirement can be predictable and also scalable. So next, line network topology, which is common in Ethernet CAT, and it consumes lower cost of hardware. The next is the ring topology, so which is redundancy, but it has extra overhead. Next, the key design considerations. So that are the bandwidth margin. That is always when we are designing the communication system, we have to allocate some amount of bandwidth for its extra operations. That is of 30 to 50% of spare capacities to allow future expansion, bursty traffic, as well as diagnostic purpose. Next is the key parameter is the latency and jitter. So if we are increasing the bandwidth, it does not guarantee that the jitter or the delay latency will get reduced. It's also critical for motion control as well as synchronization applications. Next, network segment. So the users are it is used in VLANs and also separate the control and IT traffics and also manages the switches. Error handling and retransmissions. So here noise and EMI in industrial environments increases the packet losses. Retransmission also increase the effective bandwidth. Because of retransmission, the effective bandwidth is get reduces. So for typical bandwidth requirements for applications, based on the applications, the bandwidth requirements are calculated as for simple sensor applications, the bandwidth requirement is less than 100 kilobits per second. And in case of PLC IO, it is of 1 to 10 megabits per second. For motion control, it is of 10 to 100 megabits per second. Vision system, it is 100 megabits to gigabits range. SCADA is a low bandwidth and it has produces high latency tolerance. So based on the applications, bandwidth requirements are considered and accordingly the system is designed. Because of that, the data rate is get improved. Thank you.